Hello, today we want to talk about Chapter 6 in your Physics 1 textbook entitled Electrical Energy and Charge. We're going to talk about electrical energy, talk about the idea of electric charge, and then we're going to talk a little bit about charging objects, which could be kind of fun, the idea of electric force. So here we go. Electrical energy can be created by many means. The left-hand slide, the voltaic cell, illustrates the experiment that you did for Chapter 5. The aluminum foil, the copper penny, the cloth soaked in salt water, and this generates an electric current that flows through the circuit and could light the light bulb. This is a type of what's called a wet cell. Dry cell batteries are illustrated on the right, and this is another source of electricity. You put these in your flashlight. Depending on the shape, you can put them in your MP3 player or put them in your cell phone, and you get an electric current. Now, of course, we also get electricity through electric generating plants, whether it's hydroelectric or coal or oil burning or whatever. We can generate electricity that way to put it to work. There is electricity at work in a very striking and exciting way. Lightning bolts are nothing but a flow of electric current. This one is quite vivid. Other ways we put electricity at work, of course, we let the electric current flow through the light bulb in our house and we have light. We let the electric current run the microwave oven and we can warm things up, or we can cook dinner, or we can do whatever. And of course the television set is run by electric current, and so that we can see and hear what's going on in the world. Now, we need to talk a little bit about atoms and electrons, because electrons are the source of the electric current. This is a helium atom. It's a very small atom. It has 2 protons and 2 neutrons in the nucleus. It has 2 electrons going around outside. Now, the moving electrons are responsible for electricity. Electrons will be generated and flow through a wire, either be generated by a chemical reaction with a battery or by some other source of generation with a power plant. But the key is that these electrons are negatively charged, and the protons are positively charged. Of course, the neutrons have no charge. So, a couple of basic rules here. Like charges repel each other. If you put 2 positively charged materials together, they're going to push each other away. Unlike charges attract each other. You put a positive and a negative charge together and they're going to be drawn to one another. Now, static electricity is kind of an interesting and fun thing, and the girl in the picture is demonstrating how you can generate it. You take a balloon and you rub your hair with it, and the electrons move from the balloon to the hair, and the hair is pulled out to stick to the balloon because opposite charges attract. If electrons are moving from the balloon is going to be more positively charged. The hair will be more negatively charged, and so the hair is attracted to the balloon. Now, the hair sticks out because like charges repel. The hair has electrons. They're all negatively charged, so those hair strands are going to repel one another and the hair is going to stick out. Now, there's a couple of really vivid examples of this. The girl on the left may have rubbed her hair with a balloon, or she may have brushed it real strongly, but anyway, you can see the hair pieces repelling each other. The girl on the right is touching what we call a Van de Graaff generator that generates electricity. It's not enough to shock her, but it's enough to send electrons through, and you can see her hair is really standing up because all of those electrons are repelling one another. Okay, this was a short one. It's a very short chapter, but got a couple of interesting and worthwhile points to it. Electricity is a general term for anything involving an electric charge. Generally, we consider electricity to be the flow of electrons. Atoms have charged parts. The proton in the nucleus is positive, and the electron going around the nucleus is negative. And like charges repel, so protons would repel one another, opposite charges attract. So protons and electrons would be attracted to one another. Now, friction can add or remove electrons and can cause materials to become charged, as we've seen with the balloon rubbing the girl's hair. You can transfer electrons, and the balloon and the hair will be attracted to one another. The different strands of hair will be repelled because they have the same charge. So there it is. It's a short but hopefully informative lecture, and we'll talk to you later.